Approximating a binomial distribution with a normal distribution. If we have a large number of trials and we are wanting to know the cumulative probability over a range of values, we have a problem. For example, suppose we had the binomial distribution. X is a binomial with 100 trials and a probability of success 0.45. And we wanted to find the probability that X is between 38 and 51 inclusive. We do not have cumulative tables for n equals 100, and there is no simple formula for calculating a range of binomial probabilities. There are calculators which can do such calculations, such as the Casio ClassPad, which I'll show in a second, and the TI Inspire. I do have a Casio ClassPad, and here's a picture from it. And you can see binomial CDF, and we can just stick the values in here. But at the time of writing, these calculators are not allowed in examinations in the UK. In my opinion, this is a good thing, as using these calculators teaches nothing about the actual distributions. And I can speak to this with some authority because I've done exchanges in countries where they do use these calculators, and students in the UK tend to understand the distributions much better in my experience. The way that we get around this problem is to approximate the binomial distribution with a suitable normal distribution. For X following a binomial distribution with n trials and a probability of success P, we know that the expectation of X, or the mean, is NP, and the standard deviation of X is the square root of n times P times 1 minus P. And remember that the parameters for a normal are the mean and the variance, which of course is the square of the standard deviation. So we can approximate this binomial with parameters n and p with the normal distribution with mean np and variance n times p times 1 minus p. In order to visualize this better, consider the following. X is a binomial with 50 trials and a probability of success 0.5. That distribution looks like this. Now consider that the expectation here would be 25. We can see that that's in the middle here. And the standard deviation would be approximately 3.54. So let's use y is a normal 25, 3.54 squared. And let's add that to this graph, and you can see that it fits quite well. In this case, the fit was very good. We started with p equals 0.5, so the original binomial distribution was symmetrical, and of course we know the normal is symmetrical, so that's a situation where we'd expect a very good fit. What if our binomial was less symmetrical, however? Well, in this case, I have a binomial with 50 trials and a probability of success of 0.2, so it's quite skewed. The expectation would be 10, and the standard deviation would be about 2.83. So we could use a normal 10 2.83 squared and fit it onto the graph. which you can see we've already done. It was done at the start. While the fit isn't as good, just look at where I've got my cursor here, and you can see it's under here. It still isn't terrible. Generally, the normal is a better approximation when n is large and p is close to 0.5. But as we can see here, the fit isn't terrible. And even with a probability of 0.2, if n is much larger, we get a better fit.